In this question, we are asked to find the inverse of the matrix M, where M inverse exists, and also to determine for what values of K the matrix M is singular. So if you've not done this question, I suggest you pause the video now and attempt this question before looking at the solution. So we might as well start by finding the determinant of the matrix M. And we know it doesn't matter which row or column we expand this determinant by. So to me, a sensible choice seems to be the middle row, but you could easily pick any row or any column. So remembering our matrix of signs, we have negative k multiplied by the determinant of 3, negative 2, negative 1, 4, plus 0, lots of 1, negative 2, 2, 4, subtract 4, lots of 1, 3, 2, negative 1. Well, if we calculate this, we have negative k, 3 times 4 is 12, subtract negative 1 times negative 2, which is 2, plus 0 times this determinant here, but we know that's going to be 0, subtract 4, lots of 1 times negative 1 is negative 1, subtract 2 times 3, which is negative 6, so we have 12 subtract 2 is 10, so this is negative 10k, negative 4 times negative 7 is positive 28. So the determinant of this matrix M is negative 10k plus 28. Well, we may as well address this second part of the question now. From what values of k is the matrix M singular? Because we know that M is singular if and only if the determinant of M is equal to 0. And we can now see that that happens when negative k plus 28 is equal to 0, and that happens if and only if k is 2.8. Okay, so let's go back to find the inverse of this matrix M. And actually, for this inverse to exist, we need that the determinant of M is not equal to 0, i.e. we need k is not equal to 2.8. Okay, and if this is the case, we then know that M inverse is equal to 1 over the determinant of M. And then we have a nice big matrix here of our cofactors. So our first cofactor in the top left corner corresponds to the element 1. So this is the cofactor 0, 4, minus 1, 4. And then our second cofactor corresponding to the element 3 is k, 4, 2, 4. But remembering our cofactor, our matrix of signs, this has a negative sign. Our third element corresponding to the element 2, negative 2 in the top row is the determinant of k, 0, 2, negative 1. On the second row, we have the determinant of the matrix 3, negative 2, negative 1, 4. But again, remembering our matrix of signs, this takes a negative sign. The middle element corresponds to the element 0. So this is the determinant of the matrix 1, negative 2, 2, 4. And then the cofactor corresponding to the element 4 is the determinant of the matrix 1, 3, 2, negative 1. But again, remembering this takes a negative sign. And then onto the bottom row, the cofactor corresponding to the element 2 is the determinant of 3, negative 2, 0, 4. And the cofactor corresponding to the element negative 1 is 1, negative 2, k, 4. Remembering this comes with a negative sign. And then finally, the determinant corresponding to the element 4 is 1, 3, k, and 0. But remembering really, really importantly that we need to transpose this matrix. Okay, so let's go about calculating this. Well, we know that the determinant of M is 28 subtract 10k. And if we calculate all of these individual determinants, we have 0 times 4 is 0, subtract -1 times 4 is +4. K times 4 subtract 2 times 4 is 4k plus 8, but this has a negative, so 4k, negative 4k plus 8. And here we have k times -1, which is negative k. Subtract 0. 3 times 4 is 12. -1 times -2 is +2, so we get 12. Subtract 2, then we have a negative, so that is -10. The next element is 4 plus 4, so that is 8. The next element is -1, subtract 6, which is -7, but we have a negative here, so that is +7. The next element is 3 times 4, subtract 0, which is 12. The next element is 1 times 4, subtract -2k, so 4 plus 2k, but this is negative. And then finally we have 1 times 0, subtract 3 times k, so this is -3k. And then we have a reminder to transpose. So all we need to do to complete this question is to transpose this matrix, and then we have the inverse of M in terms of k, provided k is not 2.8. So the first row becomes the first column, so we get 4, -4k plus 8, -k, -10, 8, 7, 12, -4 plus 2k, and then -3k. And that is our inverse matrix M, provided k is not equal to 2.8.